So, good morning, grade 11. So, today we're doing a lesson on the animal nutrition. So, this is your revision lesson to make up for yesterday, the lesson we couldn't have for load shedding. So, I'm using the SWAY document that we use for our kids at school. And first, before we even talk about nutrition, we want to know why we eat food. And you eat food because the food gives you energy. And the energy you produce from eating food from cell respiration is used for movement, respiration, sensitivity, growth, reproduction, excretion, and nutrition. So you can remember it as Mrs. Green. So you need energy for the 7 characteristics of life. Now, when it comes to food, and we know food is very important, food is passed on. So the energy from the producers are passed on to the consumers and then the decomposers. Now let's look at the different types of food. Let's look at herbivores and let's look at the different skulls. Now, this that you see here, it's just showing you the flow of energy from producers to consumers to decomposers. So the food from the producers are actually passed on to the consumers and then to the decomposers. That's what a food chain is. It's a flow of energy. Now, let's look at a herbivore. A herbivore, if you look at the skull of a herbivore, you can see there's the big diastema, and a diastema is a gap. And that's the place where you can see all the teeth are there except there's no canines. And that's the gap. So that's the gap because that's where the canines would have been. If you look at the premolars, molars, and the incisors, they're all very flat. They're flat and broad. And that's perfect for chewing, crushing, and grinding. Okay. And the plant material needs a lot of chewing. Okay. And if you remember, I also told you that herbivores have 3 stomachs. And they eat lots of grass. They have 3 stomachs, and what they do is they bring up their food, they regurgitate their food, and they carry on chewing, and then they swallow their food again. So they have 3 stomachs to allow for that. Okay, so there's no canines, as you can see here. That's why there's a gap. There's it there, diastema or gap, and the molars are flat and broad or square to allow for crushing, grinding, and chewing of the food. Okay. Now, let's look at a carnivore. If you look at all the teeth, even you can see there's your incisors and canines, which are always sharp. Here's your premolars and molars. If you see your premolars and molars are also sharp. So all the teeth are sharp. And that is for crushing, grinding, and chewing. The incisors and canines are usually used also for biting and tearing and for holding the prey. Okay. Now, with omnivores, of course, we have incisors and canines are in the front, and they're sharp, and that is for biting, tearing, cutting meat. And our premolars and molars at the back are flat and broad for crushing, grinding, and chewing food. Okay, so that you can do your classroom activity from your textbook if you want to. Now let's look at the digestive system. Okay, before we even talk about the system, let's look at the terms. Important terms you need to know. Now, ingestion is a taking in of food through the mouth. Digestion is when large molecules of food are broken down into simple, most important, soluble so it can enter the cells. Okay, so when large molecules of food are broken into simple, soluble substances. Mechanical digestion is when this digestion, large molecules of food are broken into simple, soluble substances, but physically or mechanically. So this happens by your teeth, crushing, grinding, and some parts of your body actually have muscles that contract and relax and physically break down food. You also get chemical digestion. Now, chemical digestion is when a large molecule of food is broken down to a small soluble substance, but in the presence of a chemical substance. And the chemical substance will be, as you know already, HCl, and then enzymes. So wherever enzymes are, chemical digestion takes place. Okay. Now, let's look at the different types of teeth we have. Yes, we have incisors and canines for biting, tearing, cutting food. And then you have premolars and molars for crushing, grinding, and chewing. Now, here we have to talk about tooth decay. You see, now in the day that we're living in, we eat more processed food. And to make food taste better, there's a lot of sugar. And to preserve food, a lot of sugar is used because the sugar will dehydrate the bacteria. And because there's more much sugar in our mouth, then bacteria will break down these sugars at night and produce a weak acid. And this weak acid is what will cause cavities in the teeth, in the enamel, and that's how cavities form and you get tooth decay. Now, how do you prevent tooth decay? Okay, washing your teeth, flossing, especially brushing your teeth at night, and then avoid sugary foods. Okay, now let's talk about the whole process of digestion. Let's go back to our picture on the top. Now, when it comes to the first part, and I remember telling you that digestion just doesn't begin when you start eating. Because your body is used to getting food at a certain time, your acid will start producing a lot in your stomach. And that's actually what happens. If you smell food, if you know you have nice food, so you will start salivating and you will start producing a lot of acid. And then ingestion will take place. So we ingest food through the mouth. Then you will crush, grind, and you will chew the food. That will be physical digestion, because the teeth is physically crushing, grinding, and chewing the food. And then the tongue is moving around, moving the food, and then the saliva is secreted by the 3 glands in your mouth. And the saliva mixes with the food. The bolus helps to form a round ball structure. And this process is also known as mastication. Now, this takes place in your mouth. Also in your mouth, you have an enzyme that breaks down carbohydrates. So in the mouth, physical and chemical digestion takes place. Then the tongue helps to form the bolus, which is the round structure of the food, and the tongue pushes the bolus past the pharynx. And the pharynx is basically your throat. And the pharynx gets pushed downwards into the esophagus. Now, from the esophagus till the rectum, you have very important muscles. You have circular and longitudinal muscles. And these muscles will contract and relax and push the bolus down the esophagus into the stomach. Now, this wave-like contraction and relaxation of the muscles is known as peristalsis. Now, there's a page in your textbook where it has the different layers, where it has the longitudinal muscles, the circular muscles, it has the submucosa, the mucosa, and the serosa. Please make sure you know those cross-section of the muscles of the alimentary canal. It's in your textbook, so make sure you learn how to draw it. Now, peristalsis takes place, which is the wave-like contraction and relaxation of muscles, and the food is pushed from the esophagus into the stomach. The esophagus on the inside is a mucous membrane, and that also helps the food to be pushed downwards. It becomes slippery. The esophagus is slippery, so it allows the food to slip, the bolus to slip nicely into the stomach. Now, the stomach has hydrochloric acid. So immediately, if you took in any food through your mouth, if you took in any bacteria through your mouth, through your fingers, from your eating, the hydrochloric acid is an antiseptic, and it will immediately kill all the bacteria. You also have an enzyme in your stomach that breaks down proteins. So you have chemical digestion that takes place in your stomach. Then the walls of the muscle contract, the walls of the stomach, which is made up of muscles, will contract and relax and break down food as well. So in your stomach, you also have physical digestion that takes place. And all of this food is now mixing. The hydrochloric acid, the food, the enzymes are all mixing. And digestion is taking place, physical and chemical digestion. And the hydrochloric acid is destroying the bacteria. And when this substance leaves and goes into this part, which is the duodenum, the substance that leaves the stomach is called the chyme. And what you need to know is the chyme is acidic. So what happens is the gallbladder stores bile. So the bile and the chyme will mix. Now bile is alkaline. And so the bile will neutralize the acid in the chyme, so that the enzymes from the duodenum in the small intestine can now function. Now let's talk about the liver and the gallbladder. The liver produces bile, but the gallbladder stores the bile. So that's the function of the gallbladder. The liver produces bile. The liver deaminates excess proteins. So excess amino acids are broken into urea and uric acid. That's deamination. So make sure you know that term. That's a nice term most teachers like to ask. And that takes place in the liver. The liver stores fat-soluble vitamins. The liver produces bile. The liver stores glycogen, which is very important for us. The liver Also, when the red blood cells are broken down, stores the iron. And the liver is one of the main organs in your body. It's an accessory organ, meaning it produces substances for digestion but not directly involved in digestion. And the most important one is the liver detoxifies your blood. So whatever drugs, alcohol, or medication you take, the liver breaks that down. Now, when you drink too much alcohol, the cells in your liver die and turn into liver cirrhosis. That's the condition. So the cells will die and turn into scar tissue, and the condition is called liver cirrhosis. Now, it's fine if your liver fails, because you can get a partial liver transplant, because that small piece of the liver will grow into the new liver. Okay, unfortunately, it doesn't work like that with kidneys. So that now is the function of the liver. Let's move to the pancreas. The pancreas is extremely, extremely important. The pancreas, if I'm going to just now move to my whiteboard, it's something you need in matric. So you have a normal blood glucose level. And your normal blood glucose level is 5 to 7. So when your blood glucose level goes too high, that's because you're eating too much carbs. In your pancreas, you have special cells called the islets of Langerhans. And specifically, it's the beta cells. And the beta cells secrete insulin. And what insulin does is insulin will cause the excess glucose, firstly, to be turned into glycogen and then stored in the liver. You have to use the word excess. Insulin also causes excess glucose to be sent to the muscles. Why? Because you use this glucose for cellular respiration. That will decrease your blood glucose level and bring it back to normal. So this is very important. Okay. When your blood glucose level goes too low, how? By fasting or starving yourself. Then you have in the pancreas the islets of Langerhans, but you got the alpha cells secrete glucagon. Please make sure you know how to spell this. And then already in your liver here, you can see you have glycogen, stored energy for you. So the glucagon causes the glycogen in the liver to be converted into glucose. And that will now increase the blood glucose level and bring it back to normal. So this is how the pancreas actually works to control the amount of glucose. So the pancreas produces insulin and glucagon that controls your blood glucose level. Now you get two types of diabetes. You get type 1 diabetes, which is an autoimmune disorder. Autoimmune disorder means your white blood cells are fighting your pancreas and causes it to stop producing any insulin. And this happens in young kids, and they now have to inject themselves with insulin. Type 2 diabetes is as a result of old age or incorrect diet. Excuse me. And what will happen is when you're older or because of your diet, then your pancreas doesn't produce enough insulin. And that's not so serious. You can take in medication and you can exercise and you can change your diet. So that is now the function of the pancreas. Now, in the duodenum, we know the bile neutralizes the acidic chyme. So the pancreas and the liver we've just done are accessory organs. Now the bile neutralizes the acidic chyme, so that's one of the functions. The bile also acts as an antiseptic, and very important, the bile emulsifies fat. I mean, it takes the fat and breaks it down into droplets. The reason for that is you don't have many enzymes in your body to break down fat. And so there we are here in the duodenum. The pancreas will also secrete pancreatic juices with enzymes for digestion. And now we go to the small intestine. This is the jejunum, It's the biggest part of the small intestine. Then you have the ileum. Now, the small intestine is very, very long. It is long because your food must completely be broken down and increases and allows for and must be absorbed. So that's what happens at the small intestine. All food is completely broken down and absorption takes place. Now, what does it mean? All carbohydrates will be broken into glucose, proteins will be broken into amino acids, and lipids will be broken down into 3 fatty acids and 1 glycerol. Now, let's look at I just want to look at the picture of the villus, if I can find the picture of the villus. The picture of the villus is extremely important. Okay. I cannot see the villus here. So the villus is very important. You must make sure you know how to draw the villus. Now I'm going to quickly go through these notes and see if I've done everything. So there's peristalsis. There's the longitudinal and circular muscles, and you can see them contracting, relaxing, and pushing the bolus along. Here's your definition. This is what bile does. Okay, the functions of bile. This is chemical digestion. For your enzymes, this is all you have to know. Carbohydrates, proteases, and lipases. Okay, so here's the adaptation of the small intestine. Okay, the small intestine is 7 meters long. Okay, and now I'm going to just quickly look for just going to pause. Now I cannot find the diagram of the villus, so the best thing for me to do is to draw a villus for you. So as I'm drawing, hopefully you're drawing as well. So this is the single layer of the columnar epithelium that covers the villus. Okay, so it's the single layer of columnar epithelium. And then on the villus, you also have microvilli that also increases surface area, so more nutrients are absorbed. And then you have these structures like this. And these are your blood capillaries or your blood vessels. And this is where your amino acids, your vitamins, your water, your salts are small, and your glucose are small enough and can enter the blood vessel. And then if you remember, in the middle is a very important lymph vessel called the lacteal. And the lacteal, that is where the 3 fatty acids and the glycerol are absorbed. They cannot enter here in the blood vessels, or they're too big. Then that's the villus. Then you'll have your crypts of Lieberkühn. This will be your crypts of Lieberkühn. It will be in capital letter because he named it after himself. And here you'll have your Brunner's gland that secrete mucus. So the villus is finger-like structure to increase surface area, so more nutrients are absorbed. Microvilli increase surface area to increase the absorption. You have a single layer of cells, so nutrients can be absorbed faster. You have your blood vessels to absorb the amino acids, the vitamins, water, glucose, salts. You have the lacteal, a specialized lymph vessel that absorbs the fats. Crypts of Lieberkühn and villus and Brunner's gland secrete mucus and intestinal juice. See, intestinal juice, and U with the mucus. So remember, so the intestinal juice and the mucus makes the villus moist, so nutrients can be absorbed faster. So that is now the adaptations of the villus. Make sure you know the adaptations. I sent you a note of it. And with the small intestine, if they ask you the adaptations of the small intestine, is folded 7 meters long, so more nutrients are absorbed. It has villi and microvilli to also increase the surface area for absorption. Okay, so that is now the small intestine. So I'm going to go back to my diagram. So we've done the mouth, we've done the esophagus, we've done the liver, we've done the stomach, we've done the gallbladder, we've done the duodenum, we've done the pancreas, we've done the small intestine. Make sure you know the villus. Now, I was telling, I thought you guys should know that sometimes your gallbladder, they might ask a question that if you don't have a gallbladder, why must people not eat a lot of fatty foods? Now, a gallbladder stores bile, and bile helps to break down fats. So if you have few enzymes and now you don't have a gallbladder to store fat bile, you cannot eat lots of fatty foods because you don't have a lot of enzymes and bile to break down the fats. That's why theoretically they tell you that a person that doesn't have a gallbladder should eat less fats because they don't have any bile stored to break down the fats. So that's just a nice question they could ask you. So that's the small intestine now. We've done the small intestine, and that is where food is completely broken down, and that is where absorption takes place. And absorption is when the nutrients, which you saw, is taken into the blood. The blood will carry the nutrients to the cells, and the cells will absorb them. Now, undigested food, food that we don't have enzymes to break down, will now enter from the small intestine and go into this part here. This is the cecum. It's the blind ending of the large intestine, but the large intestine, the other name for it is a colon. So I'm going to use the word colon. The blind ending there, the bottom, that part is the appendix, and you know the appendix stores waste. When you don't have an appendix, you don't store waste, so you actually don't need an appendix. Now, all that undigested food and water moves up the colon. This is the ascending colon, this is the transverse colon, this is the descending colon. So as this undigested food is passing through the colon reabsorbs the water and vitamins. And then that undigested food will go to the rectum and will still be stored there. And then bacteria turn this undigested food into waste. And when the rectum gets too full, then egestion takes place, where undigested food is removed via the anus. And that's egestion, elimination, or defecation. Now, when you have too fast peristalsis in the colon, then you have diarrhea. And that water that you're busy losing is water that your body needs. So a person with diarrhea can dehydrate. When you have constipation, then you have too slow peristalsis in the colon. And then the feces become too hard in the rectum and it's hard to push out. So everything has to do with peristalsis. Now, roughage is fiber or bran. And roughage promotes peristalsis here in the colon, so that you won't be constipated, you won't have problems. Roughage absorbs toxins. Roughage also prevents cancer of the colon and hernias. And it's very important that you have fiber, which is basically roughage. So you don't have an enzyme to break it down, but it's very useful for your body. So this is now the digestive system. So I'm going to quickly go through the notes and check that we've done everything so that you're not disadvantaged. So we did why we eat food, the flow of energy in the food chain, the skulls that we must know and be able to identify. We learned the parts of the digestive system, the terms we did. Tooth decay, yes. Peristalsis, there's a nice picture. Peristalsis is the wave-like contraction and relaxation of muscles along the alimentary canal. We spoke about bile. So there's that term there. When bile breaks down fat into droplets, emulsification. Chemical digestion, there's all the chemical digestion. This is all you need to know. Absorption, we've done in the small intestine, when the small nutrients or molecules are absorbed into the blood vessels or the cells. We did the small intestine, absorption we've done, assimilation. Now, if I draw my cell, and if I draw my mitochondria here, when that glucose is absorbed and used by cellular respiration, when those amino acids are used in the cell membrane, that is called assimilation. So when the digested nutrients are used and become part of the cell, that is called assimilation. Now, we have to know about this circulation, which is important for the transport of digested food. So this is the hepatic portal circulation. Hepatic means liver. So this is a portal vein. Can you see there? A portal vein has blood capillaries on either side of it. So there's the blood capillaries, there's the blood capillaries. So this is just one side. It's showing the veins. If it showed the arteries, it would be too confusing. So you can see all the veins from the stomach, the spleen, the pancreas, the small intestine, the large intestine, all enter through the portal vein. And they're all carrying the wastes now. Then they enter the liver, remove the waste from the liver, and then they enter and leave the liver by the hepatic vein and then join the inferior vena cava. And that's how the wastes are taken to the heart. Now, in that way, the hepatic arteries, the splenic arteries, the pancreatic arteries, all of those arteries will now carry nutrients to all these different parts of the body. So this is the hepatic portal circulation. These are the blood vessels that will now be involved in removing the waste from digestion, and the arteries from these blood vessels, from these organs, will carry now the nutrients. So this is the hepatic portal circulation. That's a circulation that carries the nutrients from the small intestine, and that is the circulation that supplies nutrients to all the parts of the body. It's called a portal vein because it has blood capillaries on either side of it. Hepatic means liver. We've done the functions of the liver. We've done digestion. Very important, homeostatic control of blood glucose levels, insulin and glucagon. We spoke about diabetes mellitus, which is basically also known as type 2 diabetes, and I've spoke to you about type 1 diabetes. Let's go to this quickly. We know that we eat food for energy, different diets. Yes, infants, toddlers must have a lot of breast milk because it's perfect nutrients with antibodies that they need. Teenagers need lots of growing. They do a lot of growing, so they need a lot of proteins and calcium for strong bones and muscles. Pregnant women need a lot of protein foods for a lot of growth for their baby. They need a lot of vitamin C and D, folic acid for iron, and calcium and vitamin D for strong bones. Elderly people don't eat as much and shouldn't eat so much proteins because they don't grow so much. A vegan is a person who doesn't eat any animal products. A vegetarian just doesn't eat meat. Halal, you all know what that is. And then kosher, these are Jewish people. They don't mix milk and meat products. If they eat meat, they have to wait at least 6 hours before they can drink dairy. And I know that their fridges have to have their milk and their meat separately. Dietary supplements, that's what we do to supplement our diet. Like right now, we're taking a lot of zinc, we're taking a lot of vitamin C to boost our immune system. So whatever you're lacking in your immune system to make your immune system stronger or to supplement your diet, make it better, because we're not having balanced diets, those are called dietary supplements. Then malnutrition, when you get too little or too much of a certain nutrient. Malnutrition we can talk about usually is caused by poverty or lack of education or your lifestyle. First one is kwashiorkor. Kwashiorkor is when the child has kwashiorkor and they don't have a lot of proteins, and their hands are thin, their legs are thin, and they have their pot bellies because their bellies are filled with air, they're inflamed, and they live in areas where there's not much of food. And the people don't donate meat, people give meal. Marasmus is general starvation. Yeah, these children live in these areas, they don't get any food at all, and they're extremely thin. Anorexia and bulimia are psychological conditions. Anorexia is when the female refuses to eat food. Bulimia is when she eats food, but she binges. Obesity is when you live a stationary life and you eat too much carbohydrates and lipids and you don't exercise. Allergies is when your immune system reacts to a certain substance, and that is foreign substance is the antigen, and then you will start producing antibodies, and you will also produce histamines, which can cause certain reactions, and then that's why we need to take antihistamines against the reactions of the histamines. Lactose intolerant is when people cannot take the lactose in milk, and they will have bloating, stomach cramps, vomiting, and diarrhea. And then we spoke about alcohol and drugs and how it affects the digestive system. So I'd like to show you the questions here, and we'll do that now. I'm just going to pause. So now we look at the diagram. So I give you a few minutes to look at the diagram. Then you can pause it, look at the questions, and then And here's the memo here for you. Here's another question that we did with the girls. You can pause it. Here's the answers. Thank you. I hope you enjoyed the lesson.